dear student, this is Devang Shah from LG Institute of Engineering and Technology. We have been learning the subject basic electrical engineering, and in basic electrical engineering we have been learning the chapter which is called a transformer. Now in some of the topic we already discussed in our previous sessions, like magnetic materials and BH curve, then transformer and their constructions, then working of transformer and EMF equations, ideal transformer and practical transformer, then three-phase transformers, and in our today's session we are going to discuss about auto transformer. Now why we have to learn about the auto transformer? Because it is not a separate two winding transformer like within a one core. If we are employing two separate primary and secondary windings, because of this I have to separately handle these two windings, but instead of this two separately windings I am going to take only one wire, and that wire I am going to wound over a coil, and within a same wire, within a one wire I am going to get both the windings, primary winding and secondary winding separately on a same core. So uh, let's start with the auto transformer. So where there are two types of auto transformer, where one is called a fixed tapping type, and another in fixed tapping type there are step down auto transformer and step up auto transformer. The another type of transformer is called the continuous variable type transformers, wherein we are much interested in a continuous variable transformer in this type, where if you go by step up and step down auto transformer, let's discuss the first step down auto transformer. Now in general, by the equation, if you remember, the step down transformer, that means V1 is greater than V2 here. That means if I can write the in terms of the transformation ratio K, where K is less than 1, that means here V1 is greater than V2. That means here the value of V2 or the voltage V2 is lesser than the V1. That means this operation is defined as a step down, where you can see here only one winding is employed here. Only one winding is employed here, and in this particular one winding, if you find in this particular one winding, if you find the number of turns of primary winding here is greater than the number of turns of secondary winding. So here if you apply N1, which is a number of turns of primary winding, here N2, which is number of turns of secondary winding, where N2 is lesser than N1, that means this operation is a step down, where V2 is lesser than V1. Within a one winding you will get primary winding as well as a secondary winding. That's why it defined as an auto transformer. Now you go by a step up auto transformer, which is exactly reverse of step down auto transformer, where here V2 is greater than V1, right? So here you can see from this circuit diagram, where the number of turns of primary winding N1 is less than number of turns of secondary winding N2. Since this operation is step up auto transformer, where we have employed only one wire, right, one winding, and within a one winding you will find primary as well as secondary, right? Now if you discuss about the continuous variable type, wherein we are much interested, where you can see there is a one circular core, and within a one circular core there is a continuous wire, or within a one wire you wound or this make this coil, where you apply the sinusoidal signal V1 and between terminal P and N, and I am taking this viper, or you can consider as a handle, which is continuously moving throughout the coil, right? So once you move this viper, that means automatically the number of turns of either primary or secondary is continuously going to change, right? So if the number of turns of the winding is continuously going to change, that means within a one wire you can now separate it out, primary winding and a secondary winding within a one assembly. So that is what the best advantage, where within a one winding you will get both the primary and secondary. That's why this terminology is defined as a auto transformer, right? So here see, this particular handle is now moving in a circular way, is going to rotate, and once it is going to rotate you can fix it at any position and you can adjust or you can vary the number of turns of primary winding as well as number of turns of the secondary winding, right. So by that way, at one point of time you can vary, or you can adjust, or you can set N1 is greater than N2, which is called a step down transformer, and N1 is less than N2, which is called at a step up transformer, right. So within a one assembly you can get both the step up and step down transformer using this theory, or using this terminology is defined as a auto transformer. Now let's discuss. See, this wiper is moving in a rotational direction, so that is continuously change the number of turns of primary and secondary. By that way you can get both the operations, right. Now if you discuss about the application of auto transformer, we can use this auto transformer in a booster, in a auto transformer starter, like for a motor and generators. In electrical locomotive devices we can use in a furnace transformer, right. Some of the advantage of auto transformer, like is required a conductor material which is a very less conductor material, because within a one wire you will get both primary and secondary winding. Same way, it obviously having a low cost, low size and high voltage ampere rating, because of the size of the transformer is less, right, and you can also achieve a high efficiency, right. Same way, the better voltage regulation you are going to achieve in a auto transformer, and small amount of no load current, which is also in a advantageous way. Now let us discuss about the disadvantages of auto transformer, where it has an isolation problem, because within one wire you are using as a primary winding as well as a secondary winding, right. Same way, it has a less safety and higher short circuit current, right. So these are the disadvantage of auto transformer. Now let us discuss about the construction of auto transformer, where how you can save the copper in a winding, because at such this is only a one winding. So obviously you are going to save the copper. Now in what amount of you are going to save the copper in auto transformer, let us discuss gradually. So because of one winding it uses a less copper and hence it's cheaper. So it is used where transformation ratio differs little from unity. Figure shows both the step up and step down transformer. So you can see this particular figure, where one is the step down transformer, the first one, and the second figure B is the step up transformer. You can see here, we can just discuss here step down transformer, the figure number A, where you can see the primary winding, the number of turns are N1, the secondary winding number of turns is N2, where V1 is greater than V2, which is available at the load. So if we are talking in that terms, then I can from the transformation ratio I can take V2 divided by V1 is equal to N2 divided by N1 is equal to I1 divided by I2 is equal to K, right. So for this step down transformer, let's say if we calculate the weight of copper in section A to B, you can see this from section. So for the weight of copper you can calculate from for the section A to C. This will offer a number of turns is N1 minus N2, right, multiplication where the I1 current is flowing, right. So from this you can find the weight of copper in section A to C is proportional to N1 minus N2 into I, right. So ultimately this is a one kind of N into I, it's a one kind of magnetomotive force that, but we taken in terms of the proportional. So here the weight of copper in section A to C is proportional to N1 minus N2 multiplied by I1, right. Same way, if we talk about weight of copper in a section B to C, so from B to C, which is offering the number of turns is N2, and the flowing current is I2 minus I1, right. So I can write the weight of copper in section B to C is proportional to N2 multiplied by I2 minus I1, right. So if I am taking the total weight of copper in this auto transformer is proportional to the summation of above these two weights of copper, which is proportional to N1 minus N2 into I1 plus N2 into I2 minus I1, right. Now this is the total weight of copper in an auto transformer, but if you are taking the separate transformer where you are taking a separate primary winding and separate secondary winding, let us discuss about those weights. So total weight of copper in an auto transformer, thus we carry forward this equation from our previous slide, and if two winding transformer were to perform the same duty, the weight of copper it's in a primary winding is proportional to N2 into I2, right. Same way total weight of copper in both the winding, I can consider total weight of copper in a normal transformer is proportional to N1 into I1 plus N2 into I2, right. Same way, if I am going to take the ratio of weight of copper in an auto transformer to the weight of copper in an ordinary transformer, and that is above these two equation, if I am going to apply, then N1 minus N2 into I1 plus N2 in bracket I2 minus I1 divided by N1 into I1 plus N2 into I2, right. If I am taking here the ratio of N2 divided by N1 and that I converted into a K, once you are going to solve this complete equation in terms of K, then you will find 1 minus K, right. So this ratio stands for 1 minus K. So I can write the weight of copper in an auto transformer, the first one, is equal to 1 minus K terms of weight of copper in an ordinary transformer, right. So if I consider here the saving of copper in an auto transformer is nothing but WO minus WA. WOA stands for the weight of copper of a ordinary transformer minus a weight of copper of a auto transformer. So that is but the WO or W0 minus 1 minus K of WO that you find from the above equation. So from this you can be able to take the K into WO. That means the saving of copper in an auto transformer is nothing but a K times of weight of copper of a ordinary transformer. So by this way you can save that amount of copper weight total in an auto transformer. That's why it is offering you a less weight of copper in an auto transformer, right. Now from this you can be able to find the application of auto transformer throughout. So this one of the application to give the small boost to distribution cable to correct the voltage drop, right. One more auto starter transformer to give the 50-60% of full voltage of an induction motor during the starting, as furnace transformers for getting convenient supply to shoot the furnace winding from 230 volt supply, and interconnecting transformer in 132 kV by 330 kV in a system, right. So these are the some technical applications of auto transformer, right. So here what we have learned about the construction of auto transformer and how we can save the copper in a construction of winding of primary winding as well as a secondary winding in auto transformer, right. Same way you can find one more application which is called in a control equipment, the one phase and three phase electrical locomotive applications. Students, thank you very much. If you find any difficulty, please write in a comment box. Thank you very much.